Just connect to there. Okay. I guess before I get started, I should have just asked how's everybody doing? Good? We're all good so far? Okay. So I haven't posted this week's homework yet, and that's because I haven't figured out exactly what I want to assign you guys. I try to make the homework assignments at least somewhat, I don't know, interesting / a tiny bit challenging, but then I don't know, it's hard. It's it's hard to write good assignments here, so I hope to get that up as soon as possible. Okay. Okay, today we're going to talk about getting data into R, but let's recap what we've done so far. So in week 1, we covered data structures, which covered things like vectors and matrices, lists, data frames, and all of that stuff, the factors, all of those things. Also how to subset your data. Okay, and then last week we talked about programming functions and managing flow control in your R programs, running loops and things of that nature. And again, in the big picture of things, kind of the first half of the course focuses on kind of the tools of R, just learning, getting familiar with the software tools that you are using. And so I intend to cover a little bit on text processing and some graphics. And then the other half of the class is dedicated to computational statistics, and I have to cover optimization, and I'll try to cover simulation. There was a request on Friday about machine learning, and so looking at kind of the outline of courses, machine learning is technically supposed to be covered in 101C, which is statistical learning and data mining. However, I'm gonna try to get in touch with the professors who cover that class, see what they cover, see what they don't cover, and if we can find a reasonable kind of some topics that are machine learning based, but not going to be covered again in 101C, or at least something that I can relate back to computational statistics, I'll try to do that. But no promises here, okay? The key difference between computational statistics and machine learning is that with computational statistics, you are using the power of a computer to answer statistical questions that would otherwise be very difficult to answer. So simulations are a good way to answer these things, and optimization is a specific application of computational statistics. So it's so that's good. Machine learning, you're also using the power of a computer, but what you're trying to do here is you are trying to recognize patterns. So either you're going to classify data into categories, or do other kinds of pattern recognition in the data. So they are related in that they're both heavily computer-based, and you need to be kind of fluent in handling computer language and stuff. But in terms of the types of questions they answer, it's a little bit different. So, but you know, it's all R related, and again, we're covering a lot of tools in R, and so we'll see what we can do. All right, so this week, today I'm going to try to cover getting data into R, and there's all sorts of stuff to talk about there. In particular, I want to show you some cool stuff you can do in terms of getting data into R from the internet, and we'll try to cover text and character data. And then on Wednesday, I intend to do an extended dplyr tutorial. So I'm going to open that up to both my 102 this class and 101 class, and I'll invite the 101 students to come early at 3 o'clock, and I'll spend the I don't know, 2 hours going through dplyr, which is in my opinion a very useful package in manipulating your data and getting it into something that you can analyze, or pulling out the information you want. So anyway, all sorts of tools available, and so some packages. Okay, let's talk about input from a file. Okay, so I imagine many of you are already familiar with something like read.csv and read.table. Yes? Okay. And so these are ways to get data into R from like a text file. You know, you've got so in 101 we use all sorts of text data. You know, it'll just be something really boring, like a CSV file, that if you open in Excel it looks like this, but it's really a plain text file with just values separated by commas. And so in our case, the numbers of interest are, you know, this field is like the height, or the arm span of a person, and this is the person's height, and it's collected, and all of these things are separated by commas, and R reads this stuff with read.csv. Okay, but there's also scan and read line, which I'll show you right here. You know, can read in just text. Okay, so read line. Let me see if I can do this without messing things up. Okay, so read line is a way to kind of, you know, in your function you can prompt the user for some kind of so I'm going to create some kind of input here. So I'm going to create a function called test. All right, and it's just going to say we're going to do x is read line, and the prompt is you'll say please type something in, type something. Okay, and then you can do print, or we'll do cat. We'll do cat concatenate you typed, and then whatever it is that they typed, x. Okay, and so this is the probably the dumbest function we can program here, but we're going to do it. Okay, and so I say, okay, let's do test, and it says please type something. So I say okay, and I said and it says you typed okay. All right, and so, you know, you can prompt the user for things, and this actually doesn't look so good. I'm going to put colon and then /n to indicate a new line, and then let's run that again. And so it'll say test. Okay, please type something. Oh, I guess it didn't process. I don't know. Okay, so I'll say hello. And then there you go. Okay, so you can prompt the user using the command read line. Okay, and then scan. Well, then we can just say take the output of scan. Scan will read some kind of file, and you tell it what to expect. Okay. So generally, with scan, you'll probably tell it expect character data. But if your file is a bunch of numbers, you can say I'm gonna send you integers or double or whatever it might be. Okay. So I was debating whether I wanted to give you this assignment or not. So here I have the text of the Constitution of the United States, which, you know, in America we're like so proud of our Constitution, right? But I guess in other countries, people don't really care about I don't know. Well, so anyway, you know, you go to DC and you go to the National Archives. And you guys have all been to DC? Okay, some of you, okay. You guys all have to go to DC. If if you call yourself an American, go to DC one day and check out the National Archives and well, anyway, okay. And so, you know, see, it says all of this stuff, and then so this is constitution.txt, and let me just make sure my current working directory is this correct one. So I can say, you know, let's do, we're going to call this text, and we're going to do scan, and we're going to read constitution.txt, and then I'm going to tell it to expect character. Okay, and then it says, oh, okay, I read 77,584 items, which apparently is about how many words exist in the Constitution. And then, and if I go to the environment, I have a bunch of stuff. We can see I have a vector, so called text, and we can print out the first 30 words in there, and it says, "We, the people of the United States." But it also, you know, includes the commas and stuff. So basically, you know, every time it found a space, it did stuff. So with text processing, and I don't know how much we'll get to today, you know, there's ways to clean this up. You can say, get rid of all punctuation through what's called G substitute, G sub. And you say, if you see punctuation, get rid of it. Or, you know, turn everything into lowercase so that, because R is case sensitive, right? So, you know, if we have we, capital W, we want it to be, the same. But then, you know, then you can do an analysis on this thing of text. You can say, you know, what are the most common words in the Constitution? And it's probably going to be the and is and are and things like that. But then you can start to filter out things that are already very common, and then you'll probably see things like justice and liberty and whatever else that you know, makes us America. So anyway, and I'm not even sure which, is this the current version of it seems like the current version, but you know, when you buy a history book, they always have all these like lined out things, right? Like, we added this amendment so it gets rid of prohibition and stuff. Okay, so anyway, so these are just some basic commands to get stuff in from a file. And we have some really good packages to import data. So read.csv is good enough for like a lot of your day-to-day cases, okay? But then maybe you get a CSV file or a text file or something that's like 50 megabytes big and has like, you know, thousands or, you know, hundreds of thousands of records, okay? Read.csv is going to run slowly in those cases, okay? And so there is a package reader, read.r, and this is like, and it's read_CSV, okay? And this works much faster than read.csv. And so let me see if I can kind of demonstrate this. So I've got vehicles.csv. Okay, so we're going to call this cars. Is cars already a data set? Cars is already a data set. Vehicles. Vehicles is not. Okay, so we'll call this vehicles. And I'm going to do read.csv, and vehicles.csv is the file I want. Okay, and see if you can pay attention to how long it takes before the little prompt goes. Okay, So it's going because it's like 14. So you know, it didn't feel that long, but that's 14 megabytes. Let me see if I do library read R. Okay, I'm going to call this vehicles2, and we're going to do read underscore CSV. Wow, it hated me for that. Okay, well, live demos are always risky for these reasons. 18,000 problems, that's a lot. Read.csv. See problems, okay, for more details. No, I'm scared. We'll see, okay. Muffle, okay, well, when it works, it's great. Although, okay, I'm not quite sure why it's choking on me here. But anyway, see, it looks like the same amount of data got imported here. Vehicles 1 and vehicles 2. One nice thing about so if you have library dplyr loaded, let's see. So vehicles 2, when you have when you use the reader functions to read in, vehicles 2 is a table df, and so it only prints what fits your screen, and everything else it'll say, okay, there's all of this other stuff that's not going to fit on your screen. Whereas when it comes in on read.csv and you just say, I want to take a look at this, it's going to try to print everything as much as it can, and it's like you're like, oh, that's nice, I guess. And it, you know, it takes up your entire screen buffer, so you can't even see anything that you did before. So so that is another nice thing about package reader. Let's see, okay. And Hadley Wickham actually does a presentation himself called Getting Your Data into R, and it covers a lot of the stuff I'm talking about today. Just talking about, you know, if you want to get Excel files in, this is a good package to use. There is, I think, like a read.xls or something. And then if you're trying to get data in from another software package like SPSS, data, or SAS, Haven is the package you want. And of course, you guys know how to look up help on the internet for different things. Okay. There's also a package downloader. So all of these packages I'm kind of showing you, I recommend you do the install.packages, you know, this package, okay, because they are useful. So there is package downloader, and R already has a function called download.file, and package downloader just puts a wrapper around it, okay? It just uses download.file. Sometimes download.file chokes when you ask it to go to an HTTPS site, like a secure website. Sometimes it chokes. It says, I don't know how to do this. It's asking me for security stuff. And so package downloader puts a wrapper around it and allows it to handle these HTTPS sites. There are other functions like curl, which does the same kind of stuff, but curl, I think, is a little bit harder to use, where downloader is pretty straightforward. Of course, all of these things, after you install the package, you should just go online and say R package downloader and look up the help files or the manual pages for that. Okay, there's another package called Lubridate, which I guess is a fun play on words there, because handling date and time functions in R is, well, if you don't use Lubridate, it can be very frustrating. And so so the LubriDate package makes it a lot easier, okay? So for example, let's say we have these text strings, okay? So here, I'll come over to R, and we're just going to put these text strings here, okay? And so if I say, sdate1, it's this thing, and we have to tell R, hey, this is actually, it's not text, it's actually a date thing, okay? So you say library LubriDate, and then you say, okay, well, sdate1, what's it in the form? It's in the form the day followed by the month and the year. So you say dmy string date1, and it says, oh, okay, I know how to read that. You're talking about this date, okay? And then so when it's like this, R recognizes this as a date thing, okay? And then so there, with this thing, you can add, 10 days later, okay? And it's oh, this is actually 10 seconds. But you can do operations with dates on just something like this, okay? And if you want to turn sdate, or we already have that, into this date, you just say, okay, well, this is month, day, year, sdate2. Okay, so it's very very easy. Okay, if you wanted to do it the old-fashioned way, oops, using R's built-in date functions, you have to use this thing called as.date, and then you have to specify the format that it's in. Okay, and then so %, little d stands for the day, %, big B stands for a month that's written out, and then %, Y stands for a 4-digit year, okay? And because there's no space between 6 and August in 2005, you have to put this thing here, and it will recognize it. If any of this is wrong, okay, so let me just, if any of this is wrong, let's say you used a lowercase y, then it gets confused, okay? Because it sees the 2005, and so it says it thinks you're talking about 2020. Or if you mess something up here, or if you're if you say day, month, year, and you put in the M, it says I don't know what you're talking about, okay? And so the LubriDate just makes it a lot easier that you don't have to worry about these functions, these formatting things, because if any of these are just off by a little bit, right? And LubriDate's also smart, right? Because maybe not everybody, like you're collecting data from some kind of web form or something, and you ask them to input your birthday or something. And so some people write it this way and other people write it another way, okay? With the old function, you had to kind of do a bunch of cleaning up and say, blah, all right? Anyway, LubriDate just makes your life a lot easier, okay? Because this used to be like the worst part of statistics or data analysis was just wasting time cleaning up data because it got messy. So anyway, install LubriDate, look up the help. It's good stuff. All right, so this is what I think this is so cool. We'll see if you guys are convinced or not. Okay, so this is called package ARvest, and it's like harvesting from the web, okay, or web scraping. And so, well, I have to make a disclaimer here. So a lot of websites don't like when you send robots to scrape its data and do stuff with it, because it's like they want people to look at it and not robots. So, just be careful that you're not going to tick off any website owners if you're going to use ARvest to gather stuff, okay? You use ARvest in connection with something called the selector gadget, okay? And so you're going to go to selector gadget, and then it says drag this link to your bookmark bar, okay, which I have put here, and here I've got selector gadget, okay, in your bookmark bar. So you need this thing to really do stuff with ARvest. And then here's once you install package ARvest or library ARvest, you can type in vignette selector gadget, and it shows you kind of like how to use this thing. You type this into R, and then a little HTML window will pop up. Okay, and then but before we get into the use of ARvest, it uses a package called Magritte, and it uses this operator, which is called the pipe. And so Magritte is like some artist who did this thing, which says this is not a pipe, and because it's a picture of a pipe. It was in that, what was that movie? Or book, Fault in Our Stars. They made a big point of it. Okay, anyway. So it takes the output of one function and pipes it into another function. Okay, so let me just show you. So here, let's say we wanted, this is silly, but let's say I took the numbers 1 through 1,000, and I said, I only want the numbers divisible by 3. Okay, so it says, take the numbers 1 through 1,000, pipe it in to subset, okay? And then when you put the dot, it takes whatever the result is, and it puts it in the place of the dot. Now, normally when you type in subset, you have to say subset this object, comma, the conditions on which it's being subsetted, okay? But the Magritte package, what it does is it assumes that whatever you're piping in is going to be the first object. So this thing is, in essence, the exact same thing as writing a subset, okay, C1 through 1,000, and we're going to subset 1 through 1,000 where it's divisible by 3. Okay, so if I do this, it will give me all the numbers divisible by 3 up to 1,999. And if I do this thing, it gives me the exact same thing. Okay, so can you see how this and this say the same thing? Okay, and so it's especially helpful when you're going to pipe one thing into another and do a series of functions, because in R you can like nest the results into another thing, and then so if we want to further subset this, okay, right? I want to further subset this result, and I want to take it where this result is, I think in the demo I said is less than 200 and greater than 800, or greater than 800. With the pipe function, I can just say take the result and then do another subset operation here, okay? But if I want to do that over, you know, by nesting things inside of each other, I have to take this result, okay, and then I'm going to say, and then put it inside the subset function, and then say, well, and do it where that result is less than 200, or the same result is greater than 800, okay? And then lastly, we're going to pipe all of that output into the standard deviation function. And so, and so the standard deviation of all of these numbers is that. But, you know, just to show you that this indeed filters out all the numbers that are between 200 and 800, you can see it gets rid of everything there, okay? So, so it just kind of helps in keeping track of what you're doing, because I think this is a lot easier to read in terms of going back and understanding what you did than trying to understand what happened here, right? So, but you know, you get the same results, okay? And so, you know, here's some things with a data set. So with something like this, I think it's very clear. You're going to take empty cars. We're going to subset it where horsepower is greater than 100. Okay. I don't know if you guys know function aggregate, but basically what it's going to do is it's going to group together a whole bunch of stuff based on cylinder. Okay, so if I didn't do aggregate, there would be like 30 cars with 4 cylinders, and oh, I don't know about 30, but like a bunch of cars with 4 cylinders, a bunch of cars with 6 cylinders, and a bunch of cars with 8 cylinders. Okay, but aggregate is combining all of them together, and the way it's combining them is the use of the function, and we're rounding everything off to 2 decimal places. So it's doing all of these things, and it's rounding them off to 2 decimal places. And then lastly, it's going to change our miles per gallon into kilometers per liter, via this operation. Okay, and it prints out the table. Okay, and you can get the same result through this code, and this code, actually probably might require fewer text and lines, but I think it's easier to follow what is happening in this form than it is when it's nested inside of each other. Okay, so let's do our ARvest demo here. Okay, and so with ARvest, we can go to the internet. Okay, and so our demo is we're going to go to the Lego Movie IMDb page. Okay, and this is what the website looks like. Okay, and so let's say we wanted to extract something like the rating 7.8. Okay, so what we're going to do is we're going to turn on selector gadget. Okay, and then you so selector gadget turns everything into like little clickable things, and you say, okay, well, I want to get this number right here, 7.8. Okay, and then when you click that, what it's doing is it's looking at like the HTML tags, and it says, oh, you clicked this thing. Does that mean you want all of these other things? And you're like, no, I don't want all of this other stuff. So you click this thing, and it says, get rid of that. Okay, and then so now it's reduced the highlighting stuff, right? And they say, well, and I still don't want this, so you click this, and you get rid of that, and then so now the only thing I think is highlighted is that number 7.8, and we can check, and it seems correct. So it says, okay, the way you're going to select it is using this tag here. Okay, so I'm going to click this and copy that. Whoops. Okay, and then I come back to R, and let's I'm going to say library ARvest, and then we'll also use stringer later on, so we'll do that. Okay. So, well, I'm going to tell it. I'm going to use this function read underscore HTML. Okay, and I give it the address of the website. Okay, and so this basically goes to the website, and then it's going to read all of the HTML, right? So you go to page source, and it looks at all of this stuff. So we tell it to do that. Okay. Okay, and then it's done that. And if I just do like a Lego underscore movie, okay, it says, okay, you've got an HTML XML document, and it's got all of this stuff here. Okay, and so you can see the text that we've done, but I'm going to say, okay, so I've saved read HTML into this thing object called Lego movie, right? So I'm going to say Lego underscore movie, and what we want to do is we want to identify the HTML nodes, okay, that have the keyword strong span, okay? Because that's when I clicked this thing and I said I don't want any of this other stuff. It said the way you're going to identify this thing on the page is with this keyword strong span, okay? And then we say, okay, I want to do that. Okay, and if I hit enter, it says, ah, I see, you got this thing right here. Okay, and so this is, it's figured out the object that we want. Okay, but what we actually just want, we just want this number 7.8. Okay, and so because it's contained within this HTML tag, which is this bracket thing, or less than greater than thing, we pipe the result of this into HTML underscore text. Okay, and it says, okay, there you got it, 7.8. And then lastly, we want to turn this into a number, so we say as.numeric. Okay, and so that's the thing that we have, and then we can say, okay, take that result and store it as a rating. And there you have it. Now we've successfully told the computer to pull out the rating here. Okay, so I can now use this, and I can go to a different web page, right? I can go to this is Goosebumps is in the what? All right, well, okay. Oh gosh, what am I doing here? Did the website change? Or is like okay, let's go to the top 250 movies. All right, so let's see, there's got all this extra crap that I don't want. Okay, but I think this is just the page. This is for the Shawshank Redemption. Okay, so if I were to say the URL of the movie is this page, it should successfully extract 9.3, right? That's what we're hoping. So we're going to call this Shawshank. And so this will be read underscore HTML. Quote this. All right, so we do that. And then I'm going to take the exact same thing that I did for the Lego movie. Okay, and we're going to just put in Shawshank. Okay, and then so we told the computer do this thing, and it says, oh yeah, I know what you're talking about. The rating there is 9.3. Okay, so you can, using these tags, you can get the computer to, learn how to read. Although it says 9.2 here. Oh, IMDb, you shady. You're saying it's 9.3 here, and it's only 9.2 on your top 250. All right, so I don't know what. Can't trust you anymore. Okay, Goosebumps. I guess they made a movie out of it. All right, so anyway, so that's one thing. Okay, you can even do. So let's say we want to get the cast, right? So let's we'll use selector gadget. Oh, I gotta hurry up here. Okay. So let's say we want Will Arnett's name. Okay, and we want Elizabeth Banks' name. Oh no. What did I do? Is this everything I want? I don't. But we want to get rid of these things. So you have to kind of make sure it's not highlighting junk you don't want. Okay. I don't think we want the actual the box. We just want the text, right? So this is how we identify item prop. Okay. So selector gadget. We tell it. Oh, apparently it used. I guess when I did it earlier, I got something else. But let's see. So I do Lego underscore movie, and we're gonna feed it into select the HTML underscore nodes. That so I'm using what I just got with selector gadget here, and let's get HTML text, and let's see what it spits out. Oh, leg movie, yeah, that's not a. That's another. Sounds like something else here. Okay, and then so it picks out. It says, oh, you got Will Arnett, Elizabeth Banks, Craig Berry. Who is that? Where's Chris Pratt? Well, it just goes off of what IMDb says. Okay, so I don't know what IMDb's sorting algorithm is, but apparently someone doesn't like Chris Pratt, and he's not even in the top 15 here. Okay. But anyway, it pulls this out, okay, and I've saved this as cast, okay, and And then you can even pull out like an image, okay? So by identifying the tag for the poster, you can get the image URL, okay? And it says here's the so if you want to harvest photographs and stuff like that, okay? And this was extracting the first review. Okay, so this is cool in of itself, but this is the next part is what I think is really awesome. You can simulate pretending to be a person at the computer on a browser, okay? And so you can tell ARvest, okay, you're on this web page, but you know what I want you to do? Not just pull stuff on this page, but I want you to go down here and I want you to click Will Arnett, okay? And then when you get to Will Arnett's page, I want you to look at his filmography and tell me all of these movies that he's worked in, okay? And then when you're done with that, go back and I want you to click the next actor, okay? Elizabeth Banks. Tell me all the movies that she's been in, okay? And then go back and keep doing that for the list, okay? So to do that in R is you say, okay, I want you to create a session, okay? And what a session does is it's like pretend browser with cookies and all of this stuff. And so S is an HTML session. And what we're going to say is that, okay, what I want you to do is, so we have the list of actors, right? So I've got cast, and it says Will Arnett, okay? And what you do is you say, start with the session, and then follow the link, follow _ link, and I can say, I can write Will Arnett in there, and it will say, oh, okay, I understand, that means I should click this thing, okay? And it says, now in my session, I've gone to this web page, where if I click this web page, that will be Will Arnett's IMDb page, okay? So, and then you can say, okay, well, now that you're at Will Arnett's page, I want you to go through and, now that you're at Will Arnett's page, I want you to go through and tell me the movies that he's worked in. So you use select your gadget, and you say, okay, I want this thing, okay? Lego Batman movie, but I don't want all this other stuff that you're highlighting, okay? So get rid of that, and this looks about right, okay? So just the Lego Batman movie and the Teenage Mutant Ninja Turtles 2 movie and Flaked, the TV series. These are the things I want, okay? BoJack Horseman, okay? And these, okay, so I use these tags, and apparently all I need is BA to select it, okay? And so that's what I've done here, okay? I've said take the session, okay? Follow the link, Will Arnett, or in this case I can just say, because cast is as a vector, I can just say cast, the first whoops. Instead of typing in Will Arnett, I can just say cast just the first item in cast, right? And then once you're there, read the HTML, and then what are we going to do? We're going to select the nodes, HTML nodes, identified by BA, okay? And then what we want there is now we want to, once we've got that, let's extract the text, HTML _ text, okay? This is pretty neat, right? And then you see hit enter, and it says, okay, I did that. And Will Arnett, he's got 189 things listed on his page in chronological order, going all the way back to, maybe not in chronological order, just a bunch of stuff, okay? So it was probably good to check and make sure you know what you're selecting here. And then so what I did was, I don't want all of this stuff, so I'm going to stick it into the function head, and I'm just going to ask the first 10 items, okay? So it goes and it does that, okay? And then and I said, okay, you know what? I also want to get the year, okay? So let's say I want this thing, okay? And let's get rid of this thing. No, but I also want this thing. Okay, and so you have to kind of click, and it says, okay, the way you're going to select that is filmography year column. How do I select this? Okay, so I give it that stuff to select, okay? And so anyway, I've put this all into a little loop here, okay? And I just said, you know, for the first 3 elements in cast, which we have determined to be Will Arnett, Elizabeth Banks, and Craig Berry, okay, what I want you to do is start at the with this HTML session, which is on the Lego IMDb page. And then what I want you to do is I want you to follow the link to actor I and read the HTML. Okay? Okay, right? For I and cast, because cast is these things. So the first I is going to be Will Arnett, the second I is Elizabeth Banks, and the third I is Craig Berry. So follow the link that says Will Arnett, then follow the link that says Elizabeth Banks, and follow the link that says Craig Berry. Okay? What you read on that page, keep in mind, is going to be called actor page. And so you don't have to say every single time go start the session and click the link, okay? So you just visit the page once, and then while you're on that page, we're going to extract the name of the movies and the names of the years, okay? And for the names of the years, I had to apply some regular expressions, which pulls out certain things, because when I just used the node to pull out the year, it pulled in like these extra characters that I didn't want, okay? So I'll explain regular expressions in the future here, okay? And do that, and then we're also going to just so we know which actor we're talking about, we're just going to take the, we're going to just repeat the actor's name in a column called name, and we're putting this all into a list, okay? And so I say for actors, so it does this. Okay, and so I'm running the loop, and it says, okay, I'm going for the first name you've given me, the second name, and the third name you gave me, okay? And then we can say, all right, tell me what you see in cast_movies. And it says, ta-da, I did this for you. Will Arnett, these are the movies that are listed in his filmography. These are the years associated with the movies that he did. And then his name is Will Arnett, okay? And then we do the same thing for Elizabeth Banks. And then we do the same thing for Craig Berry, who apparently is in a bunch of gargoyles stuff. And then there's a library called I think data table that will kind of put all of this stuff together for you. And so now you have a data frame that you can work with, okay? And so anyway, I think that's pretty cool, if you ask me, that you can simulate a session to go through the internet and start pulling out pages of information at a time. So I'll post all of this code online, and I still have to write an assignment. I don't know, maybe I should make it open-ended, or I don't know, but we'll see.